Welcome back, polar bears and polar cubs. Let's talk about the history of the periodic table. So, back in the day, in the 1900s, 1860s to be more exact, we had Dmitri Mendeleev, old Russian dude. Now he'd be an old Russian dude. He was obsessed with these elements and their properties, their chemical and physical properties, including their atomic masses. And he found that there were some similarities if you put them in a periodic interval. So if they had regular intervals, aka periods. So that's how we kind of got the name periodic table. Okay, so they're periodic. So he did this. He had these giant cards and he would lay them out, and he was obsessed with laying them out until he found these patterns. His first periodic table was in increasing atomic mass. Okay. He did it by increasing atomic mass. Well, about 50 years or so passed, and then you had Henry Moseley. With Moseley, he discovered, and through discoveries of other scientists, that it was not increasing atomic mass, but it was by protons, which is how we got increasing atomic number. Now, a really interesting fact, which was kind of freaky, actually. When you go back to Mendeleev, the reason that we say that he's the father of the periodic table is because he was so obsessive with it that he actually could tell you that there were missing elements. He knew that there were missing elements, and he could tell you actually properties of those elements before they were even discovered. And then finally, we have John William Strutt and Sir William Ramsay. And they discovered several of the noble gases. That's really what they bring to the table. Now, with periodic law, we've already kind of talked about some of those, and those were our trends. Okay, they go by atomic number and kind of tell us, increasing atomic number, ionization energies, metallic properties, atomic radii, ionic radii, and so on. The modern periodic table, through discoveries of new elements and things like that, got expanded compared to what Mendeleev could have told us. And it is according to atomic number. Notice how it's not mass, but it's protons. So let's talk about the extra kind of places or groups on the periodic table. So you have the F block. We just got done with some electron configuration, and we're talking about the F block. So the F blocks are the lanthanides and the actinides. They are shiny metals. They are mostly radioactive when it comes to the actinides, okay? And they're mostly metals that we're not going to really find. They are rare earth metals for sure. The ones that we kind of have dealt with, either most of the time in a compound, are group 1. This is part of the S block. They are known as the alkali metals. They are super reactive, like so reactive to the point that we have to store them. If we have pure alkali metals, we have to store them either in, as it says, kerosene, or we use mineral oil. Otherwise, they start to react with the air instantly. You might be going, Mr. Day, isn't hydrogen a group 1? Well, it is, but it is a unique element. It kind of goes with group 1, but it can also group with group 17. It is what we would like to say its own unique group. It gets along with other groups, but it also can be by itself. So what I always tell people is try to be more like hydrogen, fit in with a lot of people, but also be able to be by yourself. Group 2 is also part of the S block. These are harder and denser than alkali metals, so though they are called the alkaline earth metals, we can actually find these as free metals. We don't have to kind of refine them as humans. So you can find a chunk of calcium out in the world. 3 through 12, these are considered the transition metals. They are the D block. They are much less reactive than group 1 and 2. Great conductors of electricity. These are what we would consider metals. When I tell you, hey, silver or gold or copper or iron, the first thing that probably pops into your head is the fact that it is a metal. Groups 13 through 18, these are the P block, except for helium. Helium is still part of the S block. Now, this is kind of a big concept. Between the P block and the S block, these are considered the main group elements. So on your periodic table, you'll see that these numbers are like 1A or 5A. That's telling you that these are the main group. They're that main group's number. That's why, like, group 13 may be called 3A. It's the main group 3. Okay. And the reason that we have these main groups is that's also the number of valence electrons found within their group members. Okay. All nonmetals are included within these groups except for hydrogen and helium. All metalloids are actually included in group 13 through 18. The bottom left block, there are 8 metals. The big 2 special groups are the halogens, which are group 17. These are the most reactive nonmetals. They want to bond like no other. And then you have the noble gases, who have a full outer shell of valence electrons. Most noble gases have 8 valence electrons. However, helium has 2 valence electrons. So again, you have the alkali metals, alkaline earth, transition. Then you have the noble gases, the halogens. You have your regular good old groups. You have your lanthanides and your actinides. So I'm going to give you about 5 seconds. You might want to pause it. Go ahead and label which ones are which, and then we'll go over the answers. 5, 4, 3, 2, and 1. All right, noble gases, that would be the last one. That's purple on the screen. Alkali metals is the first one. That's red. Alkaline earth metals would be the second one. That's orange. The lanthanides are the top bottom row. The actinides are the bottom row. Transition metals are the white in the middle between the colors, and the halogens is the blue. So if we go up, you should have alkali metals, alkaline earth metals, transitional metals in the middle, halogens, noble gases. On the bottom, you should have lanthanides and then actinides. So this is the chart that we're talking about when we're talking about the periodic table. Okay, it used to be what we would consider 5.2. However, it's just the chart. So I was nice enough to actually fill in some orbital notation for you. So for sulfur, you have 1s, it's full. You have 2s, it is also full. You have 2p, which is also full. I filled that wrong. You have 3s, which is also full, and you have 3p, which is partially full, and then it's got a 4 part. So the noble gas notation, you should be able to complete that, having us already done 4.3. The next question is the highest filled sublevel. Well, it has to be an entirely filled sublevel. So that one, if you look, is 3s. It has 2, so we're going to write 3s in here. How many half-filled orbitals do we have? Well, those would only be these 2 right here. So we have 2. How many filled orbitals do we have? We have 1, 2, 3, 4, 5, 6, and 7. How many orbitals do we have that have at least an electron? Well, if you have 2 half-filled and 7 completely filled, you have 9. And then the question is, what block is sulfur in? It is in the P block. Okay. This is the worksheet that we're going to have you run through. Okay. before we have you work on that, I would like you guys to kind of answer these questions just as a nice quick review over what was in the notes. So I'll give you, go ahead and pause it, and you have 3 seconds, and then we'll go over them. 3, 2, and 1. Who created and who is credited with developing a method that led to the determination of the standard relative atomic mass? You might not know that, but it's Casiaro. Okay. Really just an interesting fact for you guys. Who discovered periodic law? Mendeleev. Who established atomic numbers as the basis of organizing the periodic table? That would be Moseley. Define periodic law straight out of our notes: physical and chemical properties of elements that are periodic functions of their atomic numbers. And then 3 sets of elements that have been added. Well, let's see. Noble gases, lanthanides, and actinides. Okay, lanthanides and actinides, because they're so rare of earth metals, they weren't really found by Mendeleev's time. All right, polar bears and polar cubs, go ahead and try the worksheet. And if you have any questions, just let me